All right, welcome to chapter 3. So moving on from proportions, we're going to be looking at some linear equations. So first of all, some of the things we're going to be doing in this particular section, in this chapter, we're going to review what recursion is. If you think way back from the beginning of the year in our fractals, that would be recursion. We're going to use our graphing calculators to investigate sequences. We're going to use a table to represent sequences, and then we're also going to write routines to generate sequences. So we're going to spend a lot of time on our graphing calculators. Please make sure you have your graphing calculator available to you. Let's get rid of this. So remember that an arithmetic sequence is something that is a list of numbers where each term is related to a term before by addition. So if I have something like 2, 4, 6, 8, all of those terms are related to each other because I'm adding 2 each time, right? They're related by addition. Each following term is related to the previous term by adding 2. That's an arithmetic sequence. Okay, and now remember, I should say this too. Arithmetic sequences, they're related by addition. That could also be addition of negative numbers. So let's say I have like 10, 8, 6, 4. So I'm still adding, it's an addition of negative 2. So like I said, it could be related by addition of negative numbers. Just keep that in mind. Now, what is recursion? So if I think back to something like my Sierpinski triangles, those fractals we talked about, something that repeats again and again and again. And like an arithmetic sequence, it's related to what happened before. It depends on what happened before. So remember a Sierpinski triangle where I am connecting the midpoints of all of my upward-facing triangles, right? Hopefully this doesn't bring back terrible memories for you. So I'm doing the same thing again and again and again, and it depends on what I had before. That's recursion. All right, so let's take a look at how we can use our calculator to generate recursion for this particular scenario. You win $1,000 in a contest, you put the winnings in the bank, and decide to add $28 to it each week. All right, so in other words, at week 0, I have $1,000. I initially win $1,000. What do I want to do from there? In order to, let's see, our first question is how much do you have in week 12? Well, in week 1, we would add 28, right? I'm going to add 28 each time, which makes this, again, an arithmetic sequence, right? I'm adding the same thing each and every time. So rather than having to go through and find, okay, week 2, add another 28, week 3, add another 28, I'm going to punch this into my calculator so that I can just keep hitting enter in order to find what I need to find. So pick up your calculator and follow along with what I'm going to do here. All right, so first of all, I want to put in that first ordered pair that I just wrote down. I want to put in my starting week, and my starting value. So my starting week is 0, my starting value is 1,000. I'm going to enter it just like that. So I'm going to use brackets, so pay attention to where my brackets are. So second parentheses is going to give me brackets. So again, at week 0, and here's my comma, I have $1,000. And I want to close that off with my brackets. All right, so there's my starting 2 values, or my starting ordered pair. I'm going to go ahead and hit enter. I'm going to use my brackets again, and I'm going to tell my calculator what I want it to do. So for that, what I'm going to do is I'm going to hit second, and down here, do you see where it says answer? So answer 1, that relates to my 0. So my first value is 0, that's answer 1. And to that, to find my second term, I'm going to add 1 to that. So in other words, from my 0 week to my first week, I'm going to go comma, and then I want to add 28 to the 1,000, right? So I'm going to say answer 2, make sure you're using the parentheses where I'm using parentheses, and again, what do I want to add to the 1,000? I want to add 28 to that. So what I'm saying is I'm adding 1 week each time, and I'm adding $28 each time. So again, 1 week I'm adding to the weeks, and $28 I'm adding to the money. So I'm going to go ahead and hit enter so you can see then at week 1, I have $1,028. If I keep hitting enter, there's week 2, week 3, week 4, 5, 6, 7, 8, 9, 10, 11, and 12. So now I can see at week 12, I have $1,336. So how much do I have in week 12? Again, my calculator just told me $1,336, right? Now my next question though is, let's put that down for a second. When do you have more than $2,000? So on my calculator, again, I'm going to be looking at, where'd my calculator go? So on my calculator, I want to find when that second value is 2,000. So I'm going to keep hitting enter. And I'm going to let you keep hitting that so I don't waste your time here. But when you keep hitting enter, you should see that second value eventually get over $2,000. So what is your week where that value is finally over $2,000? Again, you can do that on your calculator yourself. Let's try another one though. We're going to skip that because we just did that. Let's see. Okay, here we go. So let's try this again on our calculators. Again, we want to start with, so I'm going to start a new recursive routine on here. I want to start with my starting floor. So I'm going to use my brackets. My starting floor is the 0 floor, comma, and my initial height, so the value of that starting floor, looks like it's a basement, right, is a -4. So there's my initial ordered pair. At floor 0, I'm at -4 feet, so 4 feet below ground. I'm going to finish that off with brackets. Now again, to tell my calculator what I want to do with that is I want to add, it looks like 1 floor each time, right? So I'm going to go second answer. So to that first value, I want to add 1 floor, comma. And now to my second value, so answer 2, I want to add, well, let's see what our sequence says here. So it looks like it's plus -4 plus what is 9, 9 plus what is 22, 22 plus what is 35. It looks like I'm adding 13 to each floor, right? So again, this is an arithmetic sequence, I'm adding the same thing. So it looks like each floor is 13 feet. I'm adding 13 feet to each floor. All right, so let's tell our calculator that we want to add 13 feet to our second value. And again, let's close that off with brackets. So pause if you need to and make sure yours looks exactly like mine. All right, so I'm going to hit enter. And it looks like at the first floor I have 9, right? Well, I can already see that on my table of values here. Our question is, how high is the 12th floor? So on my calculator, I want to continue to hit enter until I find the 12th floor, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, and 12th floor. So it looks like my 12th floor is, what was it, 128 feet above ground. Now, you could have made that go a little bit faster if you want to start here on your calculator and have your initial number be 4 and your initial value be 48, and then just enter in the same rule. You won't have to hit enter quite as much. So here's where it gets a little tedious. If there are 50 floors in the building, how high is that top floor? How high is that 50th floor? So when I go back to my calculator, I want to hit enter until I find the 50th floor. Again, I'm not going to sit here and hit enter forever. You can hit enter until this value right here is 50, and you can see then what the 50th floor would be.